Hi, everyone, and welcome to the recording of a new session for the Identiverse conference. I'm Jeff Lombardo. I'm a principal identity specialist at AWS, and with me is Ram. Ram, how are you?
Hey, I'm doing good, Jeff. I'm Ram Ramani. I'm a principal data protection specialist working on the same team as Jeff. And welcome to this presentation, everyone.
So, what are we talking about today, Ram?
Yeah, I mean, today we're going to be talking about identity management for AI agents. Me and Jeff, have been working on this topic for some time, and it's very relevant in the current industry of generative AI, where everyone wants to think about AI agents and specifically how we can manage identity effectively for AI agents. All right, so let's just briefly start with talking about the AI evolution. Now, prior to 2022, we saw the emergence of solutions to problems such as linear regression or k-means clustering or nearest neighborhood searches in the vector space. And all of these were all those statistical prediction mechanisms. We used to label them as AI. And into 2023 and 2024, we saw the emergence of chatbots and coding assistants, where one could type in natural language prompts into a chatbot and get responses, or you'd use coding assistants that could do code completions. Now, in 2025, we've seen the emergence of coding assistants which can do a lot more. They've actually become collaborators where they are able to vibe code along with you and not just suggest code completions, but can also triage security issues on their own. And going forward into 2027 and beyond, we're going to see a lot of AI becoming pioneers where AI is going to suggest, or we can even call it the advent of, artificial general intelligence in some way, where the AI is going to become more emergent and be able to suggest what the humans can do instead of the other way. So let's kind of look a little deeper into the generative AI environments within how what customers are building. So if you look at a generative AI application, which is powered by an agent, you have an interaction with a large language model for reasoning and intelligence capabilities, and then you also have vector databases, or essentially the retrieval augmented generation or RAG approach, where data sources are fed in the and converted into the vector space, and then able to generate context out of that, which then feeds into the model. But then again, agent also had access to tools or essentially business logic or APIs that they could call for both within APIs that are built internally as well as those that are potentially accessible from a SaaS application that is external. Now, the thing is that although within an organization, you have access to various APIs. There are many, many untapped data and APIs that are available externally, which you may not be leveraging to actually make your user experience better. And that is why we decided to, kind of build tools. And essentially, you can see that the agent can, in addition to the other components that it's connected to, it can, in interaction with the LLM, it can actually leverage these tools both, which can be both first party and third party APIs, and leverage these tools for creating a better user experience. So what is an AI tool under the hood? Well, I kind of described the high level where an agent can call an API. However, if you look beneath what an AI tool is, it's more than an API proxy, right? It's an intelligent API gateway which is connecting into one or more microservices or APIs under the hood. And for you to build a strong identity foundation, you want to make sure that fine-grained authorization, whether the agent is acting autonomously or on behalf of a human, the fine-grained authorization flows all the way across the board so that you have defense in depth and you can build a strong identity foundation. All right, so we talked about access to these tools, which is good. However, when we introduce more capabilities, you would have, you can assume that you'll have more risks. So what are these risks? So you're talking about the risks when you're building applications powered by generative AI or with agents, but you also have to think about risks when the agent is acting on behalf of a human. Now, keep in mind that when you're building applications with agents, you have to kind of consider, as I mentioned, fine-grained permissions and the probabilistic behavior of the LLMs. But equally important is the user experience when a user or a customer or an employee is using an agent that you built. How do they think about trusting the agent or providing a set of guardrails or controls that they're comfortable with, such that they feel that the agent can they can use the agent on their behalf and it does not cause any financial or reputational harm. So you have to think about both of these dimensions when building a Gen AI application. So we talked about the probabilistic logic of the LLMs on the right top there. And then, but keep in mind, traditional security elements are also equally important when you're building an agentic application. What that means is that the AI agent can potentially use a malicious tool. It can access a resource only made for humans, or it can get confused because of a prompt injection or even otherwise due to hallucinations, and it can potentially select an unrelated action that you don't expect it to perform. Now, all of this can be controlled with deterministic access control logic and having fine-grained permissions that are built well. And if you do this right, even if the probabilistic logic, which the LLMs or the reasoning capabilities lead to an undesirable action, you're still protected. So for you to build a strong identity foundation, it is critical for you to think about traditional security and make sure that your deterministic access control is done right. Now, when an agent, in this case for Alice, is acting on our behalf, she's got two options. One is she decides that, hey, you know what? I trust that the agent is going to act on good faith. Let me just give my credentials to the agent. Now, as you probably know, giving credentials to any delegate is not a good idea, right? So it's definitely something you don't want to do. Now, the second option is that you are able to use a consent-based model where it's kind of like a human in the loop interaction. For every action that the agent is taking, it comes back to the human and says, hey, can I do this? Is this something that you trust? But it's kind of effective to a certain degree. However, it can get very overwhelming if the number of consent requests become too many. And at that point, the human himself is going to say, hey, you know what? I'm going to probably not deal with this and then consent to everything. So there's a fine balance you need to think about when you're building with human in the loop models. But that's where OAuth and other mechanisms can potentially shine. But the fact here is that what I want to kind of set the stage for is how do you think about building a strong identity foundation that you can leverage to build a strong security posture when building applications that are powered by AI agents. So at this point, I would like to pass the mic to my colleague Jeff to dig deeper into what we can do with respect to building a strong identity foundation for building AI agents. So Jeff, over to you.
And I think that we will use a lot of the mental model you gave us so far. So if I can just represent it a little bit more different, you will find here all the agent, tool, vector DB, and first and third party APIs that we talked about. So when we want to be able to deal with identity and access control management into this ecosystem, we still want to preserve a certain number of characteristics that are like the definitive threat for 2025. We want each of the components, whatever it is, a user or a workload, to be uniquely identified into our ecosystem. Whenever the access to the data is performed, we want to be sure that it is least privileged and it is delegated by the previous actor into the chain in order to be sure that we can preserve the context and the ability to move forward into this access to the information. That's why providing a lot of context will be very critical if we want to be sure that we can respect the initial intent of the prompt or the request to our GenAI application while we are moving forward. And finally, two important points will be the ability to bound any delegation of authorizations that can happen, both to the origin and to the destination in order to prevent any replay attack or abuse of previously issued credentials. But there are more that we need to take care of. Our different components can live into different trust domain, meaning that one agent can be into trust domain A, and the vector DB might be into trust domain B, and maybe some tool into trust domain C. And that is generated some boundary into our ecosystem. We have two types. The scope boundary that might allow require us to be able to require more information or more delegation, consent from the previous actor in order to be able to perform, or trust boundary that might require us to be able to exchange what we have for something else into another taxonomy and another space to be recognized onto the other side. And what is great is that we have created an ecosystem of standards. OAuth is more than just one standard. It's a framework of different pieces moving all together that can allow us to being able to achieve those different use. So let's see, how can those standards can help us moving forward onto the mental models that Ram talked about. So if we are just taking like the explanation that a tool is an intelligent API gateway, we can see still what are the features that we can host over there. The first one, which is one of the most important, is the ability now, thanks to the OAuth protected resource metadata standard, for the AI tool to be able to broadcast or to expose what are its capabilities. That will allow any component that needs to interact with it, so in this case the agent, to understand what he can achieve with this tool and how it should gather information or delegation of authorization in order to be able to talk to it. So if now we are representing this AI tool into our trust domain A, and we say that there is only one trust domain and there are no scope boundary, or at least only one scope boundary into our ecosystem, now that we talk to the metadata endpoint, the agent can use the token it just received before, pass it to the AI tool. The AI tool can, with this orchestration logic, decide to reuse the token with a specific service API endpoint. And if everything is okay, the resource will be returned to the tool in order to be returned to the agent, in order to be returned to the previous actor. So that's the API path. And now we can try to dig in what the un-API path can be. For example, let's say that when I'm passing the token to the AI tool might say, okay, I have a different scope boundary if you want to talk to me. Okay, so we need the AI tool to be able to provide signaling onto that. One of the good way to do it is what we learned through the step-up authentication standard that can allow us to, through a 401 response, to signal to the agent that the agent is missing scope into the current token which is provided, and that the agent needs to take action onto that. Such action can be like doing a new authorization flow with the authorization server of the trust domain A in order to gain access to a new set of token and to reuse the new access token into a new request to the AI tool. And if the AI tool is satisfied, it can reuse this token with the backend service. And if the backend service is satisfied, then the resource will be returned. Okay. But what can be the other kind of scope boundaries that we can find over there? It can be at the service API. The AI tool might be okay with the current token, but it might be the service API that might have a different scope boundary. So in this case, it will be the service API that will return the same type of step-up authentication response in the form of a 401 with signaling in order to say to the AI tool that something needs to be done. And what the AI tool can do is that it can generate its own authorization request to the AS of the trust domain A in order to get a new token. For this to happen, for sure, this AI tool will now need to have its own identity in form of a workload identity. And I will come to that a little bit later. But let's say that this is achieved, he get access to a new set of token, use this new set of token with the backend service, and if everything is okay, the resource will be again returned to the agent. So let's deep dive a little bit inside this notion of workload identity. How can we provide a workload identity to those AI tools? There are multiple ways we can do that. We can pre-create a client, a OAuth client app configuration at the authorization server beforehand and just pass the information through a config file to our AI tool to be able to operate onto that. But that might be the old way. We might want something of more dynamic, more time limited, or maybe assured through a digital signature. And we already have that into our ecosystem. Like, for example, Kubernetes is providing some identity token to any pod that is found inside the namespace, inside a cluster. So we could use that. We see also the emergence of Spiffy and Spire, which are like the ability to create some verifiable identity document to the AI tool for the AI tool to be able to get some credential after that. At AWS, we are using the notion of EAM roles that we can assign to any native piece of compute that we can have, whatever it is, an EC2 instance, a Lambda function, or maybe an EKS or an ECS pod on one side and task on the other side. The overall idea is to be able to create a trusted infrastructure substrate. Now that some identity document can be passed to the AI tool, the AI tool can use another concept of the OAuth ecosystem or the OpenID ecosystem, which is the ability to dynamically register itself as a client to the authorization server in order to be able to perform new authorization request or token request afterwards in order to get initial or new tokens. So now that we have established the fact that we can have a workload identity, we can try to reduce the friction onto the actor standpoint, especially if this actor is a user. Like Ram said earlier, we don't want to create a consent fatigue over there, which the authorization request might do. And we might be into a situation where the organization might say, okay, for those use cases, I don't need you to go back to the user, to the actor, in order to get a consent. Because as an organization, I have a blanket statement that those actions can be performed and you don't need individual consent onto that. Aaron Parecki is really working onto that to try to bubble up this idea as a new standard. But let's say that it already exists. Now, what happens is that the AI tool can talk directly to the authorization server and say, hey, I have this orange token. Can you give me a green token? And the authorization server, if the authorization rules that exist and logic that allows it behind it, might effectively issue this token, which will allow the tool to use it with the backend service. And if everything is okay, the resource will be returned. Okay, so into that, that's using token exchange, which is already a standardized flow into that. But that assumes that the tool already know which copy is needed by the backend, and this can happen because it's configured like that into the orchestration logic of the AI tool, or because the service signals that to the tool beforehand with those step-up authentication mechanisms that we talked about. And that's really reduced the friction of from the end user standpoint. So now your main question might be, okay, but what happens if the agent and the service are in two separate trust domains? We start to see that our AI tool have a foot into the trust domain A and a foot into the trust domain C. So what could happen if we want to have access to the resources into the trust domain C? The AI tool may do an authorization request toward the authorization server of the trust domain C through the agent. And the user will authenticate over there, and then the AI tool will be able to get those new tokens that he will use forward. But for that, also, we need a workload identity into the trust domain C. And we already demonstrated how we could acquire that in order for the AI tool to be able to perform that. Once this token is issued, the AI tool can use it with the backend service. And if the backend service is happy in terms of authorization, it can return the resource to the agent. So this is like really using some standard authorization ground flow into that in order to be able to perform that. And again, we are relying on dynamic client registration if we want to do so. So your question might be, okay, but can I reduce friction into this specific case? You will be, because that's two standards that are currently working very hard into making this happen, to be able to cross domain boundary in order to be able to reduce the friction from a user standpoint and to do some kind of single sign-on. Again, Aaron Pareki is really working very hard to make those forward. So if you want to contribute, if you want to bring your comment and your use case, please do so. Aaron also published that to be introduced into the model context protocol specifications that I will talk about a little bit later. So it seems that we have all the pieces that can allow us to say, yes, we can achieve that. But we still feel that this is a little bit different this time. Why? It's because we are bombarded with news that says that implementation of those AI tools are not done properly. They are like leaving corner cut round. They are not properly handling those capability to delegate authorization and to store those different credentials, because they are not using the pattern we described so far. For example, you will see a lot of implementation of those tools where they are asking you to provide your credentials. And that's why it's better to go towards the specification that are currently being built in order to be sure that you are falling back onto the pattern we just described. For example, Anthropic, through the MCP specification or model context protocol that I was talking about earlier, define an open source standard which is backed by a lot of big players, and that can allow to directly use the OAuth framework, so all those specifications that exist, in order to be able to solve all those different use cases. Google A2A and IBM Agent Application Protocol try to follow up onto MCP at different other levels, but more or less, they are relying a lot onto what MCP is doing. MCP is not complete. Like I said, there are some pull requests as we speak to make it better, but it's really the standard that progress into the right way. So the standard brought us here, and they should be able to brought us there. Because when we were talking about MCP, the authorization section in MCP was not existing 2 months ago. What happened is that a bunch of identity specialists scrambled together in order to make it happen. And it really happened almost overnight. It took multiple nights to be able to go there. But they created a good foundation to start to solve problems into this ecosystem. And the best way for this to move into the directions that you want and to solve the use case that you have and to mitigate the threats that you see is just to be involved. For example, I can see this anonymous peer that just told me, hey, I only contributed to MCP because someone brought this to my attention and I thought it was the right way to move forward. So it's your turn to play. Now, I don't want to be only positive into all of that. We have a lot of work to do. If we look at the overall pool of available application, what we see is that the amount of applications which are API capable and the amount of applications that are OIDC or OAuth capable into that, the overlap of this within this Venn diagram is very small. And we need to be able to solve all the different use cases. So we know that for API capable, OIDC or OAuth capable, MCP is a very good foundation to go over there. We know that we can reapply the mental model of the OAuth standards for 2 other boxes into that, which are like the token credential, exchange mental model, or the ability to reapply OAuth even to first-party app. But for non-API oriented applications that are not OIDC or OAuth capable, that's a big world to be able to solve that. So if you want to join, again, please come to us and let's talk about it. Another type of problems that we need to look into is that when those tools are not representing users, but they are representing a group of users, like for example, a team into an action. And for that, we got the discussion during Identiverse, a very interesting in-conference sessions that happen on the fly to be able to talk about those elements. Like, for example, how to finalize the on behalf of, what it means, and how we can represent it properly in order for those resource providers to do the proper access control. How we can have multi-party delegation of authorization, or how maybe we can even do quorum-based delegation of authorization. Those are very interesting use cases that I hope we will be able to have some very good news to the next Identiverse conference in Las Vegas. So, in conclusion, what can we do now?
So one of the things which Jeff spoke about is the emergence of standards, and these standards are still evolving, and we highly encourage you to contribute. However, this field is emerging and evolving very quickly, so you have to be aware, assess, refine, and also contribute at the same time. So you have to utilize current mechanisms, adapt, and make it work for your current agentic architectures. And then, of course, as the standards emerge and get standardized, you can leverage those components as well. And the other aspect I want to bring up, which I kind of touched on and Jeff touched on a little bit as well, is about the LLM reasoning, the probabilistic reasoning versus the deterministic processes for fine-grained authorization that exists all around scope boundaries, trust boundaries, fine-grained permissions. It is very important that because of the probabilistic or indeterministic behavior of LLMs, that your fine-grained authorization strategies and guardrails are very well defined and are audited. And you want to make sure that these are tested and alongside model evaluation tests and agent evaluation tests that you may be doing. And since there's a heavy reliance on tools, you also want to think about ensuring there are API-oriented patterns for secure data access, as well as understand what these tools are potentially exposing and what tools are maybe potentially accessing these data sources that might be sensitive within your organization. So having said that, I think I'd like to conclude this video and say that if you have any more questions, you want to contribute to the standards, you have discussions, and you want to get into a deep dive discussion with us, feel free to reach out to either me, Ramani, or Jeff. And we also have posted our LinkedIn profiles. You can even hit us there, and we can deep dive and happy to answer any of the questions that you might have. Thank you.
Thank you, Ram, and I hope that we will have more recording coming very soon. Thank you everyone for watching this, and see you soon.